John says that's exactly my planned transition. Pressure tank that support multiple paddocks and multiple troughs.
Awesome. So this is gonna be super handy today. One of the nice things is for majority, if you kind of plan a little bit ahead, a lot of these systems are very modular. So you could start smaller, say with an RPS 200, RPS 400, and that's gonna be our submersible helical pump, which is great for pumping water up and out of our well. You could start there, open discharge, like I said, into a tank or into a livestock trough. And as you build up the system in the future, you can add on solar panels, you can add on batteries to get more volume and more pumping head if you want to transition over to a pressurized system later. The benefits of the pressurized system is instead of just going into one stock tank, we can go into multiple stock tanks. So basically, once we create a pressure system, it's like your utility water system, the water coming to your house. You don't have to worry about anything. You turn on the faucet, the water starts flowing, you turn it off, everything shuts down. So all of what we're going to talk about today is to automate that pressurized system, the different components you're going to need in order to accomplish that. And so we talked about why we want a pressurized system, and that's so we can do multiple tanks. We could go into a house. We could go into an off-grid cabin. Basically, we're creating our own small utility water system that we can run different applications off: household, livestock watering, sprinklers, whatever you can imagine for a water source, then you can run off of it. It gets a little more complex than a normal open discharge, but not too bad. There's just going to be some things we want to take into account before we start to make sure we have those covered as we build up this system. And so we'll start with the basics. With a water system, there's a couple of different ways we can generate water pressure. One of the most common is going to be using a pump to generate that pressure. And there's two ways we can use a pump to generate that pressure. First of all, we can use a single pump down in our well or in our other water source to pump the water up and out of the well. And then that pump can also generate the pressure and store it in a pressure tank for use throughout the day. The other way, this is much more common if you have a very low producing well. Say your well is only producing a couple of gallons a minute. You might use a stock tank or a water storage tank like you see behind me and a secondary pump to do the pressurization. The benefits with that on a low producing well is we can pump very slowly using a solar pump for 8-10 hours a day at a gallon or two a minute. And then we can use a slightly larger pump, a booster pump, in order to pump, say, 10, 15, 20 gallons a minute, even 50, 100 gallons a minute if you're doing large amounts of irrigation and watering. And that big tank acts as our reserve. And so if we're doing directly out of the well itself is acting as our reserve water supply. But if it's low producing, then we do want to add a secondary tank and have that act as our reserve. Another way for those of you maybe in Oregon with a bunch of hills around is we can use gravity to produce the pressure for us. And so with that, we can put a storage tank up on top of a hill. We want anywhere from 70 to 100 feet of vertical elevation gain. And our pump's going to pump it up that hill. And we're going to store kind of that pressure. We're going to store that energy up on top. And as gravity flows that water back down, it's going to produce the pressure for us. This is a great way with a solar pump. If you have that resource, a hill available, it'll be a great way to produce your pressure because during the day, we can pump all that water up. We can store several thousand gallons of it, say 2,500, 5,000, even a 10,000 gallon storage tank. And then we can gravity feed that during the night if you're using water for livestock, for irrigation, for household use. There's a lot of times where we want that water pressure at night. And so gravity feed's great. The other benefit of gravity feed is if anything happens to your system, anything happens to your grid, if you're using an AC pump, you can do multiple days of storage up on your hill. So if your power goes out on your AC pump, you can have 5-10 days of water storage up on your hill, even though your power's out. So a great option because gravity is always there. It's always providing that pressure. And you don't have to worry about the sun shining, batteries, anything like that. So those are going to be the two most common ways to produce pressure, whether you're doing gravity feed or using a pump in order to generate it. Let's go over why we need a pressure tank. And so I mentioned open discharge, direct drive. That's just where the pump is pumping and the water's flowing out of there. And in general, that's not good to generate pressure with because you don't want to deadhead the pump. And so if we just shut that valve off, say we're using a sprayer connected directly to our pump, every time we let go of that handle, the pressure is going to spike in that line. And the reason it spikes is because water doesn't compress. And so you think about like an air tank. An air tank, we're putting air into this tank and we're pumping it full, the pressure's going up slowly. And we're generating and storing that pressure inside the tank. And then later on, when we open the air valve on that tank, the air is going to rush out. We're storing that pressure in there. The same thing does not happen with a water tank. So if we fill a water tank full of water and we try to put more water in it, you can't fit any more water in it. It's full of water. It's a non-compressible material, that water is. And so we can't use water to store pressure for later. We have to use air to store our pressure for later. And with that, we use what you can see over here is our pressure tank. Very common. I don't know why they paint them all blue. And so you're used to probably seeing these next to houses out in the country, out in the fields. There's going to be these big blue pressure tanks, and those are storing the water pressure for later use. And the reason we want to store water for pressure for later use is we don't want the pump always running to produce that pressure. We want to run the pump, we want to charge up the tank, we want to shut that pump off, and then we can draw pressure out of that tank until the pressure drops low enough, and then that pump's going to kick back on and recharge the tank. That way, every time you turn on the kitchen faucet, your pump doesn't have to start up in order to provide that pressure. And it also prevents a lot of cycling if you have an AC pump. If you have a solar pump, and you have soft start, or you have an AC pump with soft start, we're not worried about that cycling, but you can still get weird behavior if your tank's not large enough, where you turn on the faucet, water shoots out for a second, it then shuts off, and then as that pump ramps up, the water comes back. Using a pressure tank just stabilizes that entire system, and so we can get continuous, steady pressure out of the tank, and then have the pump turn on and off just to repressurize that system. There's two main types of pressure tanks. What I have over here is what's called a bladder tank. So there's this seam here, and as part of the seam, there is a rubber membrane in here that goes up and down, and that physically separates the air from the top of the tank from the water at the bottom of the tank. That has a couple of different benefits. The older style is just a big metal tank with no separation in between. And there we just push water on the bottom, we pressurize the air, but those are a lot less efficient than these bladder types of tanks. And so a lot older style, you're going to see it's going to be more of a galvanized tank, really large. Those are going to be non-bladder tanks. They're just full of air. You pressurize them. But some of the downsides of that is over time, that air dissolves into the water, and you start to lose your air charge on your tank. And so there's a bunch of different ways that you keep those charged. A lot of times there's a little air valve, and so each time the pump starts up, it injects a little bit of air. There's also a little valve on the front here that helps bleed off. When you get too much air in there, it bleeds it off. We just found over time those parts can wear out, they can break. Sometimes you stop sucking in air. The well we have here on our property that we use every day has one of those tanks. It's not working right, and so the maintenance we have to do is once a month we have to go there. We have to drain all the water out of the tank because it gets waterlogged, and our pump starts cycling, and we have to manually refresh that tank. We're looking in the future to switch over to one of these pre-charged bladder tanks. And so these, depending on your region, these might be more common, especially if you have a newer system. These are bladder tanks in here. And so it has that bladder. One of the big benefits of this is we're going to apply a pre-charge to it. And so on the top, and this comes pre-charged from the factory, but on the top here, there's this little tire stem. And we're going to take that bladder and we're going to fill this top chamber when there's no pressure with air. Number one is that's going to reduce, or that's going to increase the size of that bladder. And so that bladder is going to end up all the way on the bottom here with our pre-charge. And what that means is we're not going to start compressing that bladder until we reach our set pressure on the lower level. So a very common pressure switch is going to be set to somewhere around like a 40-60 pressure switch is going to be very common, meaning on the low end, we're going to have 40 PSI, and on the high end, we're going to have 60 PSI. That'd be called a 40-60. A 50-70 is also common. 70 starts to get a little bit high on the pressure. If you have a newer house, you can get away with 70 PSI. If you have an older house, older plumbing, that might be pushing the limits of your appliances, your lines in your house. And so you might want to go a little bit lower. The 40-60 is usually a safer bet. And I'll talk about pressure switches a little bit later, how we can adjust those out in the field if you want to change that range. But with one of these pre-charged tanks, we're going to go 2 PSI below our low set pressure. And majority of these come from the factory at 38 PSI, which is perfect for our 40-60 pressure switch. And so that means we're not going to start, as we're pumping water in, we're not going to start expanding and compressing that diaphragm until we hit our minimum of 38 psi. And then from 38 up to 60, we're going to fill this with water. It's going to go up probably around to here, and it's going to compress all that air into a smaller area. That pump's going to shut off. The pressure is going to be maintained in this tank until we need to use it somewhere. Turn on a faucet, turn on a hose. Once we do that, then the pressure of that air here is going to push down on the water and force it out into wherever we're using it without having to turn back on our pump until we reach our low pressure. When we reach 40 down here again, the pump's going to kick on while we're using water, while we're not using water, and it's going to recharge this tank all the way back up to our high pressure, say 60 psi. So the magic of these pre-charged tanks is it just makes them that much more efficient. When we're looking at a non-pre-charged tank, say it's 100 gallons, it's going to have only about 50 gallons of usable storage as we compress that in. With one of these bladder tanks, we get a lot more usable storage. We get anywhere from 75 to 80 gallons, 80% of usable storage. So if we have a 100-gallon pressure tank, we pretty much have like 70 to 80 gallons of usable storage when we're using a bladder tank, and that'd only be 50 when we're using a non-bladder tank. So a little bit more efficient. You can get away with smaller tanks when we're using these bladder tanks. Don't worry if you have one of the older style or it's more common in your area to use the non-bladder. No problem. Just size them all a little bit bigger. They're going to work just great, and you'll have to work out some of that air recharge that needs to go on over time. Okay, we'll take a little second here, see if anybody has any questions. Do we get it in the chat or the Q&A box?
Feel free to drop in any questions if you have them at this moment. I did get one question from Laura earlier. This is kind of about pump wire with the pressure tank system.
Okay.
So she said she's going to bury her pump wire about 4 feet deep to run it from her controller to a prospective home site.
Yeah, cool.
It's roughly 220 feet. That's where the pressure tank and switch are going to be. She's wondering what wire to use. She's thinking about 10 gauge AWG wire, but she's concerned that the distance might be a little bit too far for that tank.
For sure. Yeah, great question there. So what the question is as I'm doing longer runs, whether I'm running AC wire or I'm running my solar wire, the further you go, the higher the gauge or the lower the gauge you need to have for the wire. A lower gauge with wire is going to be a thicker wire. So very common with our systems is going to be 12 or 14 gauge. Those are good up to 50, 100 feet of run. When we go past the 50, 100 feet of run, then we're going to go down to a smaller gauge, which is a larger diameter of copper. And with that, we're going to lose less voltage along the way. We're going to lose less power along the way with that higher or that lower gauge, thicker wire. And so off the top of my head, for 250 feet, doing the solar pump, the solar to the controller, we're gonna be looking probably around the 10 gauge, like you say, maybe the 8 gauge. I'm just guessing right here live. What we do have on our website, and we'll either send out a link or we'll probably put in the comments of this video later, is we do have a wire gauge sizing calculator. So super easy to use. You can go on our site, it has little scroll bars. All you have to do is enter your load, enter your system, adjust your distance, and that's gonna automatically update the wire gauge that you need for running your pump.
We got one more from Chris.
Awesome. Another question.
What about smaller pressure tanks using it in a well vault with one of our RPS pressure pumps designed not to have a pressure?
Yep. Absolutely. Great question there. Today, I was trying to keep it simple, just talking about submersible pumps, directly charging pressure tanks. One of my favorite systems here at RPS is called the TPP. It's also called the BP pump, the booster pump. And those are going to be what's called a constant pressure pump. And so when we're able to change the speed of the motor based on the pressure, we can reduce a lot of these components down, and we don't have to have the large pressure tanks. A lot of people actually don't even need a pressure tank. There's a little tiny one built into those pumps that helps stabilize the pressure. So with these classic systems, whether it's an AC pump or one of our classic solar pumps, what happens is that pump is just running either at full speed or at the amount of speed it can get based on your solar conditions. So it's just running full speed in order to recharge this tank as fast as possible. With our TPP system, our tankless pressure pump, we're able to vary the speed of the motor based upon the pressure and the amount of water being used. And that eliminates a lot of these components. And so if you're on that second option I talked about, where we want to go from a well into a tank, one of the options for the booster pump out of the storage tank into our pressurized system is the TPP. And that provides, say, 50 PSI, and it can monitor that pressure. And so it monitors that pressure and knows when it sees that pressure drop, because water is being used somewhere, it immediately turns on and ramps up to a speed to match the amount of flow required based on our water being used to maintain that 50 PSI. So if we're at 50 PSI, we turn on the sink when using 3 gallons a minute, the pump's going to ramp up. It's going to ramp up to a lower RPM, a lower speed, in order to match that 3 gallons per minute that's going out. And say then somebody turns on a garden hose at 10 gallons a minute and we're at 13 gallons a minute, the pump's immediately going to sense that and it's going to ramp up its speed really quickly to match that 13 gallons a minute. And so that's a little bit newer technology, eliminates some of these added costs. So if you're coming out of a well and you want to minimize costs and just use either your AC or your solar pump to charge this system, that's going to be a great option. You're going to use what I see today. If you're going with that second option, the storage tank, then there's a couple of things we could discuss, whether we use a TPP system to pressurize it or whether you already have some of these components and want to go with a more classic like submersible pump, booster pump. It's going to run at one speed and recharge this. Great question. I know that sounds a little complex. It's not too complex. We do have pump sizers that you can call, talk about your specific application, and they're going to help walk you through these options. So great question. Today, we're going to focus on more of a classic pressure system that you're going to be much more accustomed to on if you grew up out in the country with a well. You're going to be much more accustomed to seeing some of these parts. But if you're setting up a pump for the first time or a pressure system for the first time, we have some other options that are constant pressure to eliminate some of this complexity. Great. Any other questions before we jump on to the next part?
I think we're ready to move on.
Very nice. Cool. Let's talk really quickly about how to size our pressure tank for our system. Again, it's going to sound complex, but it's pretty straightforward. And if you have any questions, you can give us a call. We'll walk you through the sizing and help guide you on the size of the pressure tank you're going to need. The good news about these pressure tanks is they're very modular. You could start with, say, 100-gallon or 125-gallon. And if you're finding that's not enough reserve pressure, you can add a second tank and just plumb them together at the bottom, and you're going to double your capacity. They don't even have to be the same size tanks. You could start with 100-gallon and you could add on 150 or a 200-gallon later if you want that extra size. So very modular. You can start smaller and build it up. So a lot of this is going to be more for an AC pump, but it also applies to solar pump. So with an AC pump, we don't want to do more than 6 starts per hour. So we want the pump to turn on. We want it to run for at least 10 minutes before it shuts off. And that's called cycling the pump. And so a lot of pump manufacturers, including us, recommend no more than 6 starting and stopping cycles per hour, which means 10 minutes per run. And so a lot of our sizing is going to be done based on a 10-minute cycle. With your solar pump, not in AC pumps that have soft start, that's where the motor ramps up, not as important because we're not worried about burning the pump out. But what's going to happen is if you don't have a large enough storage tank, you're going to need a large enough storage tank to allow for the ramp up of that pump to start. And so if that pump takes 30 seconds, 20 seconds, 30 seconds to ramp up, we need enough capacity in our storage tank so the water that we're using doesn't diminish and shut off before that pump gets up to full speed. So if you're doing that and you have a solar pump, the 10 minutes cycle time, the 10-minute work we're going to do here still applies as a great rule of thumb, whether you're doing an AC pump or a solar pump with soft start. So what we're going to want to look at is the amount of flow rate we want to use, and we're going to try to get our sustained maximum. There's going to be times where you're going to be running a lot of stuff at once. That's going to be fine as long as it's for a short period of time, a couple of minutes sort of thing. That's like somebody taking a shower, you turn on the sink, and then somebody quickly uses a hose out front. That's going to be a larger demand than you might want to size for. But that's going to be all right as long as it's just a short amount of time. You're doing dishes for a couple of minutes, and we don't have too much overlap. So we're going to want to think about what is our most common water usage that we're going to have, and then we're going to add that up. in order to get our kind of maximum sustained flow rate. If you're doing livestock troughs, it's going to be simple. Those run at like a gallon or two a minute. And honestly, at the end of the day, is if a bunch of them turn on at the same time, it's not a big deal just to have it fill up a little bit slower as our pump runs. But if you're doing this for a household and off-grid system, then we want to look at, say, a household usage. Very common to have, say, 10 gallons a minute, 15 gallons a minute, kind of our maximum. That'd be taking a shower, doing dishes at the same time. Maybe the washing machine turns on for a couple of minutes to fill up the tub. That's just gonna, that'll be about 15 gallons a minute. If we do plan on doing irrigation or anything outside while we're using the household water, that could be another 10, 15 gallons a minute. So for a full-size house where we're doing household activities and outdoor watering, we're gonna want a size for 25 to 30 gallons a minute. That can get a little bit larger with these systems. So a lot of people off-grid, they just make sure they're going to water the plants, water the yard during the day when there's not a lot of water usage. And then they're not going to water at night when people are doing household activities. And so that's going to reduce it down to maybe like 10, 15 gallons a minute of maximum sustained usage. So a simple off-grid house, 10 to 15 gallons, a full house with outdoor watering, 25 to 30 gallons a minute. If you're also doing irrigation, you're watering a field, that's going to be higher. That could be 30, 50, 100 gallons a minute. And we're going to need to take that into consideration when we size our tank. So what we're going to do is we're going to take that maximum usage and we're going to multiply it by 10 because we want to make sure we have at least 10 minutes of that usage before our pump turns on and off. So if you're using 10 to 15 gallons a minute, you're going to want around 100 to 150 gallons of pressurized storage for your pressure tanks. If you're doing a bigger house, you might have seen these. That's a lot of times where they'll have like 2, 3, or 4 of these big tanks because they're going to want anywhere from 250 to 300 gallons of a reserve water pressure stored in these tanks, so that pump's not turning on and off and cycling. When you get to bigger systems, sometimes you add more tanks. Sometimes you just know that you're going to use enough water to match the flow rate of the pump or be close to it, so the pump's not turning on and off. You're basically just running from your pump out to your field to do that type of watering. So those get a little more complex. But for most systems, anywhere from 100 to 200 gallons of storage is going to be great. If you're in a small cabin and you're just starting out, you might just get a 50-gallon tank. I think this one's a 50 or 60-gallon tank. You might just start with one of these smaller tanks, try it out, conserve your water, use a little bit of water at a time, and it might just be enough for your usage. So like I said, those numbers also include, we need to look at bladder tanks. That's about the 75 to 80%. So you want to oversize your tank somewhere around 20 to 25%. And if you're using the older style, the non-bladder, you basically want to double those numbers. That's why those tanks are so much larger. So if we needed 200 gallons of backup storage and you're using a non-bladder tank, you'd want to probably do a 400-gallon tank. We have a 395-gallon over there to run our property because we're running anywhere from 20 to 30 gallons a minute at a time here. And so with that size of the tank, it's going to allow, with an AC pump, for it not to cycle on and off. The maximum amount of time that pump's going to turn on and off is about every 10 minutes. And not a huge deal. Like I said, our pump here, we lose charge on it. It starts to cycle. We don't want to do that long term, but if it happens for like a day or two, not a huge deal. We go out there, recharge it a couple of days of that cycling. It's not going to kill the pump, but it will shorten the lifespan of that long term. If you have the soft start, you don't have to worry about that pump and shortening its lifespan, but then you might just get weird behavior where you're trying to water and the pressure drops and then it rises back up and then it drops again really quickly. That'll indicate that you're going to need a larger storage tank. Great. Let's talk about solar pumps and off-grid considerations for our bladder tank. 2 options there. The RPS 200 through 800, those take batteries natively. You can just plug the batteries in, they're going to run. If you're using one of our larger systems, the Pro system, those don't take batteries, but we have different options in order to provide battery backup. And why I start to mention batteries is a lot of water usage is going to be, when it's household, a lot of the water usage is going to be in the morning and at night. When people are getting ready in the morning or getting ready for bed at night, that's the majority of the water usage. And those times don't always have the best solar available to charge our system. And so Your options there are to add batteries to store some of that charge. And so we can use that charge in the morning to refresh our tank, or we can use it into the evening to refresh our tanks. The systems that we don't use batteries for, you don't have to use batteries for pressure systems. That's not required. So some of you who are doing livestock watering, you can pressurize this during the day. You can fill up all your stock tanks with it. As the cattle drink during the hot weather during the day, no big deal. You're going to keep it all refreshed. And then at night, you're just going to have to rely on the water you have stored in the pressure tank. And if the cows drink in the evening and diminish this tank, not a big deal. You're just going to lose pressure in your system, but you're still going to have that water in your stock tank spread throughout your property. The cows can come, drink that down at night. When the sun comes up in the morning, the pump turns on, it's going to repressurize that system and fill up all those tanks. And so if we are doing livestock watering and water pressure at night is not critical, then a lot of times we'll just skip the batteries. We'll just direct drive our pump into the pressure system. And just rely on that. And at night, you might run out of pressure, but no big deal. A lot of times for household, that's not going to be okay. People want to take showers at night. They want to brush their teeth at night. And losing water at night can be really frustrating. Now, I have talked to tons of customers who are in little cabins off grid, and they just put a big pressure tank in. And when that sun starts to go down, they just start to conserve their water. So they try to do their water usage during the day because they don't want to add batteries to store that charge during the night. So if they have 100 gallons of storage, they just make sure they don't use more than 100 gallons at night. And if they do, they just finish off their water usage the next morning when the sun comes up. Keeps it a little simpler. You don't have to have the added expense and maintenance of batteries, but there's the trade-offs of sometimes not having that water pressure at night. But if you are more of a standard household or you're livestock watering and you want that watering at night, then you will add the batteries. Like I said, the RPS 200 through 800, we can add those in just by plugging in the controller. And then if you have a different system, we have other options, whether it's an AC inverter or our TPP system, that tankless pressure pump, that requires batteries to run, because with that system, most of the people are going to want water at night. And so that's just designed in there. So a bunch of different options. You can chat with us if you want to pump all night. Batteries are the most basic option, and then we have a bunch of others to make sure we have water pressure throughout the evening. Great. Any other questions? I think we're going to move on to components. So the fun part's up here in front of me. We got great. One question.
Yeah, we have a question from John. He said he's in an area with a lot of sugar sand, and he's wondering, is it better to install a spin down filter to prevent sand from entering the pressure tank, or is it sufficient to filter after the pressure tank?
Yeah, I think that varies on the advice. The wells I've worked on and the wells I've seen, it's to use some sort of filter or spin down before it goes in your pressure tank. For me, that's just logical. As you see all of these components, there's going to be sometimes check valves. I just figure keeping all that out of our pressure tank and any of these other fittings, our pressure switches, is going to be the best idea. I've seen other people who pressurize in here and then in their garage somewhere else have the water filters. That seems to work for them as well. So I think you can go either way. Just logically, for me, it sounds like you're the same way. Filter the sand out before it comes in. You mentioned a spin down filter. That's it's kind of this big, blue, usually they paint a barrel. It's got a kind of a bulge on top, a tube going down, and a bulge in the bottom. The water goes in the top. It spins really quick. Comes at the bottom, I think. I might have that reversed. But basically, as it spins, that centrifugal motion pushes the sand, and it forces the sand down to the very bottom of that spin down. And at the bottom, there's a ball valve here. And every once in a while, you go crack that ball valve, and you see a bunch of sand and water shoot out. That's to help prevent the sand from entering your system. There's also filters. We've used a filter in our well because we have a very sandy well on this demo one here. The filters are fine, but they get clogged pretty quick if you have that silt. You need a pretty large filter. There's some small spin down ones that we tried, worked decent, it ended up getting clogged. The ones we found best are the very large. They're usually blue, and they're a woven filter. A lot of surface area to kind of capture that silt and sand before it gets clogged up. Like I mentioned, our well here is not the greatest. We have one of those filters on it. We end up changing it about once a month and washing it out, and that works for us. But great question. I prefer filter before you get in the tank, but I also see it both ways of filtering after it comes out of the tank. Great. So we talked about our pressure tank. This is kind of the core of the pressure system. I'm not going to go into anything more on this unless any questions come up. But like I said, two different styles, a bladder style with the actual rubber bladder that goes up and down, and then just a big pressurized storage tank, no bladder. Pros and cons of each. But let's get into some of these other components we see down below. So with a pressure system, there's a couple of essential components. We have to have the pressure tank. We have to have some sort of pump to pressurize the water. The other basically mandatory type of part is we have to have some sort of pressure switch. And so if we don't have a pressure switch, that pump is not going to know when we've reached either a high or low pressure. It's just going to continuously run, and it's going to overpressurize our system, or it's just going to like reach its maximum pressure, deadhead. We won't have water flowing, and we can burn up a pump that way. So one of the keys is some sort of pressure switch that flips a switch internally to tell the pump or the controller when to turn on and off. There's two different styles here I have. This one I'm going to show you first. It's called a standard action pressure switch, if we can see in there. So obviously right now, there's no pressure on it. You can see the water comes in here. It pushes against a little diaphragm to sense that pressure. So no pressure on it. A standard action pressure switch, when there's no pressure, those contacts are closed. And so if we can see this right in close, you can see those contacts move up and down and they're closed. So that means electricity can flow up this side, flow through these contacts and back down here. That's one of the poles. This is a 2-pole switch. Electricity can also flow up here, around this side, back down on our secondary pole. When the pressure is reached, this is going to flip open. So right now, since we're less than 40 psi, its contacts are closed. When we reach 60 psi, those contacts are going to open and they're going to stop the flow of electricity down to our pump. So these are most common on AC pumps when the actual power that's powering that motor is flowing through these contacts. Say from our breaker panel, it flows through these contacts and down to our pump. And when we want to shut the pump off, we physically cut power off to that pump by these contacts opening. So again, this is a standard action pressure switch. What's more common on a solar pump is what's called a reverse action pressure switch. And so this one looks a little bit different, but the main, the bottom's the same. So it actually has a little lever so you can force it on or off. But the basics are that a reverse action pressure switch operates in the exact reverse manner. And so at no pressure, you can see the contacts are open. This wouldn't work with an AC pump because that AC pump couldn't turn on to generate the pressure because there's no power flowing. So with a solar pump, when we're using our tank full input, that is an open, an active open input. And so when the tank's not full and that contact is open, the pump's going to turn on, or that controller is going to sense that. It's going to send power to the pump to turn on. And then when that pump turns on and the pressure is reached, these contacts are going to close. And what happens when the contacts are closed is the controller can sense that they're closed and it knows, oh, the tank is full. In this case, our pressure tank is full because we reached pressure. I need to shut off that pump. Now, in these, we still have our 2 poles. You won't use both of them if you're using it as into your controller. It's just going to be used to sense whether the pressure is open and closed. The energy from the pump is not actually running through here when we're using it with a solar pump controller. It's just using it as a signal, as a sensor for our controller to turn on and off that pump. So reverse action style. Reverse action is most common when we're doing solar pumps. If you have an AC pump, you'll have a standard action switch. The best way to tell is you can see on the bottom cover, usually it'll say whether it's one or the other. Or if you have no pressure, you can just tell if the contacts are closed with no pressure, it's a standard action switch. If the contacts are open when there's no pressure, you have a reverse action pressure switch. A little bit more about this pressure switch is you can see there's these screws here. So these come set from the factory at a set pressure. Sometimes it's on the cover here. Otherwise, it's going to be on the instructions in your book that comes with it. This one's right here. This one's actually a 30-50 pressure switch, another very common type. And so 30 is going to be our low pressure, 50 is going to be our high pressure. And with these 2 screws, we can adjust that range. We have some instructions. We have a YouTube video. If you come into our instruction manual that comes with all the pressure switches, it talks about how to make that adjustment. But we also can get a little confusing. So we have a YouTube video where we go on how to make that adjustment. One of the screws is just adjusting the distance between the low and high, so that 30 to 50. So we can adjust that screw, and we can adjust the throw there, the turn on and turn off. The other one is going to adjust where that range falls. And so we can adjust that whole range down or that whole range up. A little bit confusing. A lot of times you might think like, oh, one screw adjusts the low range, one screw adjusts the high range. Doesn't quite work like that. One of the screws adjusts the distance between the high and low, and the other one adjusts where that range falls within our overall pressure. So the great news about these is you can start with one that's say a 30-50. If you want a little bit more pressure, you can bump that up on the low end of 35-40 and just adjust that whole range up. So you'll get it preset from the factory at one pressure. You can adjust it later. But let's go into some of the accessories that are going to make all that easier to do. So if you don't have something like a pressure gauge, when you're trying to make these adjustments, you're going to be doing it blind because you don't know what pressure you're at. So you're going to be like trying to turn on a faucet and just like sensing whether it's at. One of the things we love to add on to these systems is a pressure gauge. So we'll start with what's called a tank T. Tank Ts were invented to make all of this setup just so much easier. The tank T here, you can see, this is a stainless steel one, super nice. They also come in brass. Those are also great, gonna last you a long time. But if I'm doing it, I usually go stainless steel. Do it once right, don't have to worry about it in the future. This one is a 1-inch T. So we have a 1-inch port, 1-inch thread over to our pressure tank. And then we have our inlet, outlet. Doesn't matter which one's which. You can choose which one. So the water comes in here. It can flow out if you're using water. If you're not using water, it can also flow into your pressure tank here. If the water is flowing in and you're using a lot of water, the water can flow through here, and water can flow from your pressure tank to do a high usage. Say for a couple of minutes, you're using 50 gallons a minute. Sure, you can push 50 gallons a minute, even though your pump is only pumping in maybe 10, 20 gallons a minute. You can also, like, if this is shut off, then the water is going to flow in here, and it's going to recharge our pressure tank until our pressure switch trips and tells it to turn off. It's threaded on this side. This would screw down in the bottom of our tank. Usually there's an elbow on the bottom of that tank. Sometimes you need to add it. Sometimes you might want to add a T. The T is really handy. You can put the T on the bottom of there. You can add on a secondary pressure tank off of this T, and then you can add in your T here to go out with all your accessories, which we'll go over. So that can screw right on the bottom there. Super handy to get this all set up. You don't have to use this. If you want to go really basic and you just want to use a pressure switch, a lot of guys who are doing livestock watering don't care about all this extra stuff. They just use a pressure switch. They're just going to use a little like T, a bushing to get that pressure switch in there and call it good. But if you're doing a household system, you've probably seen one of these before. It'll be much more common to hook everything up. So talked about first is our pressure gauge. This is a really nice one. This is glycerin filled. If you ever seen the needle on one of these jumping around really fast, sometimes that's just caused in vibrating. Sometimes that's caused by they're just full of air. This one's glycerin, so it keeps a really stable reading. The vibrations from the pump or anything running don't affect where it's pointing to. So there's a nice port here. We can screw that in. Obviously, all of these connections, we'd use our Teflon tape if we're doing for this for real. We might use a pipe dope. Maybe we use both if we really want nice waterproof connection. So we screw that in. This makes it really easy as we're setting everything up. We don't have to guess where our pressure's at. We can always look at the gauge and tell where it's at. Obviously, we're going to need our pressure switch. We got a little riser here that usually comes with these. You might have to add it on. We're going to add in our pressure switch here. So there's always going to be sensing what pressure we're at, and it's going to be telling whether it's an AC pump, it's going to shut off power to it, or whether it's a solar pump, it's going to tell our controller when to turn on and off. This is super common to add, especially if you're doing a household system. If you're doing a livestock watering, you might be able to take a little more risk. These aren't as common, but if you're doing a household, you can see right there, maybe it says 75 PSI. So this is an overpressurization valve. And so if the pressure ever reaches above 75 PSI, this is going to start allowing water to flow out. It's going to shoot out of there because it's better to flood, say, your pump house or wherever your pressure tanks are. It's better to shoot the water out of there than have a water line in your house break and flood your house. And so this is the safety in case the pressure switch ever gets stuck on. For some reason, the pump gets stuck on and it's just running continuously and not shutting off. When we reach that 75 PSI, this is going to protect everything downstream by shooting the water out. And then once you see that water shooting out, you'll see the flood down at your pump house. You're gonna have to go down, shut everything down, and troubleshoot why that happened. So a safety here. They don't get activated very often. A lot of these are super reliable. Most of the time, if an AC pump or solar pump gets stuck, it gets stuck, shutting off. Usually it's like a little ant or something crawling into those contacts. And so we lose pressure versus overpressurization. But a great safety just in case something happens. The last one here is just a little hose bib. It also screws in this port. Hose bib's not required, but it makes it really easy if you need to drain your pressure system. So if you're down working on the well and you need to fix the plumbing, maybe you have a leak, you have to switch something out. Normally you have to run up to the house, turn on the water, try to drain the system, and then start working on your pipe. But with this, you can just directly drain your tank while you're down there working on it. So optional, just more of a convenience. Great, so that is the basics of our T and the various parts you want. The parts that are required is obviously pressure tank, pump, and pressure switch. I like the gauge to say what I'm working on. And then these two in the front are for convenience, one for safety, prevent overpressurization, the other one if we ever need to work on it. So a couple of parts I want to talk about are ball valves and check valves. We'll start with check valves. So if we're looking at our solar pumps, a majority, the 200 through 800, those are going to be called self-draining. And so that's very nice when you do livestock watering in your direct drive, especially if you have in a freezing climate. When that pump shuts off, the water is going to slowly flow back down to the pump, and that's going to prevent freezing your line. If you're in a colder climate, you're not going to be able to do that. And so we don't want that draining if we're going to be doing a pressurized system. So we need a check valve. If you're doing an AC pump, a lot of them have a built-in check valve, but most of those aren't rated for continuous pressure usage. They're just not as reliable. The reason they put those in a centrifugal pump, a centrifugal AC pump, or the Pro system is because we don't want the water flowing back down and spinning those impellers backwards, because that motor then can act as a power generator. It can actually generate power and send that back up in a system, and we just don't want that happening. So they do that built-in check valve just to prevent water from flowing back down, not to store pressure. It's not designed, the majority of them are not designed to do the water flow back plus, say, 60, 70 PSI of pressure to store it. So with that, when we do a pressurized system, we always want to add a dedicated check valve out of the outlet of our pump. So we're going to go from our pump outlet, we're going to use a little nipple, and then this is a 1-inch check valve. We're going to thread that on the top there. And this check valve is going to do a majority of the heavy lifting. This is designed for hundreds of pounds of pressure. See, it's really thick stainless steel. So this can take all the water column pressure along with the household pressure, 60, 70 PSI. It's designed for that. So anytime we're doing a pressurized system, we want to add a dedicated check valve to hold that pressure and make sure we're not flowing back down. You do have to do a check valve on the outlet of the pump. A very common question is, can't I just, up next to my tank, put my check valve up here and call it good? And the answer is no. You have to still have that check valve down on your pump. Because what happens is, if the water is up here, and we pressurize this system, the water is going to stop here, right? It can't run backwards. But this water in the line going down to your pump, what can happen is that's going to create a vacuum. Gravity is going to pull that water down, and inside that line is going to create a vacuum. And the next time that pump starts up, it's going to turn on really quickly. The water is going to accelerate really fast through that line because there is no air in it. It's not like it has to push air out. It's a vacuum. And that water is going to slam against the face of this check valve here. And when it slams against the face of that, that's going to cause a water spike, a pressure spike in your system. And that's called water hammer. And that can be very damaging to downstream because that water is going to slam against there and it's going to push that pressure all the way down, and it can spike your indoor pressure 100 PSI, 200 PSI for an instant, which can damage appliances, damage your piping, just cause issues. So in some regions, it is common to put a check valve on the inlet of this. But if you're in that region and you want to put a secondary check valve, you still need a check valve down at the outlet of your pump to prevent that water hammer. So like I mentioned, this is going to be very dependent on your region and sometimes even local code if they want a secondary check valve into the inlet of the system. In general, I don't do it. We just use one check valve at the pump, and then don't do a secondary check valve up here. But if it's more common in your region and that makes you feel more comfortable, have two check valves, you can go for it. Again, the issue can be is if your check valve at your pump is leaking a little bit, doesn't have a perfect seal, you could start to get that water hammer. It should be obvious. You'll hear it. You might feel it in the pressure lines of your house. And so if you're starting to get that water hammer because you have a secondary check valve, you're going to need to go see if you have an issue with one or both of your check valves. Great. Then let's talk about a ball valve. So a ball valve is also more for convenience. One of the things you want to be careful about is we don't want to put, if this is our inlet here, we don't want to put the ball valve on the inlet. Because what could happen is somebody who's not paying attention could come here, shut off our ball valve. Oh, this one's a little stuck. Shut off our ball valve there. What that means is when the pump now turns on, it's blocked here. The water can't flow, and the pressure switch isn't going to be able to sense that the pressure is rising in there because it's stuck on the ball valve. So one of the rules of thumb is you never want a ball valve between your pressure switch and your pump, because if someone unknowingly turns this off, you could burn up your pump, because the pump's going to turn on. You're not going to get pressure in your system. You're going to deadhead it. Either you're going to break one of your inlet lines if you have a really powerful pump that can generate a lot of pressure, or your pump's just going to sit there spinning and you could possibly damage it. So if you do want to add a check valve or a ball valve, we want to add it to the outlet here. Great. So we add it to our outlet. This is for convenience. One of the nice things about adding a check valve here is if you ever need to do any plumbing work or do any pump work, you can turn off this check valve. That's going to keep the water up in your house, and then you can use this valve just to drain your pressure tank. If you don't have this, when you turn on this valve, you're going to be draining your pressure tank, and you're going to be draining all your household lines. Again, for convenience, it won't damage anything, but it's really annoying when you fire the system back up, your house is full of air, and you have to go to all the faucets, turn it on, it sputters. You got to do that for a while to get all the air out of the system. So this is for convenience on the outlet side. If we want to add that ball valve, if we ever need to do any work, we can shut this off, keep all the water in the house, work on our plumbing here, turn it back on. We don't get all that air up into our household system. So great. That's a lot on these different components, but these are the basics of what you might need if you're setting up a pressurized system. If you're doing livestock watering, it's going to be a lot simpler. You can do the pressure tank. RPS actually has just this reverse action pressure switch on a little T with barbs, so you can just put that in line, and it creates a lot simpler system. You don't need everything else. If you're doing a household, it'd be much more common to have all these different items here. Great. Any questions before we kind of wrap up?
Yeah, we got about 10 minutes left. So if you have any questions, feel free to drop them in. Doesn't have to be pressure tank related. Anything related to solar pump, water systems, feel free to drop those questions in the Q&A.
Great. So a couple of items I mentioned, I'll just go over as kind of pro tips, like best practices. You can start smaller with a smaller pressure tank. This is like a 60-gallon. You can start with this, add on extra pressure tanks if you find in the future your water needs increase, or if you find you're getting more fluctuations than you like. Very modular. Start small if you like, add on later. Another one we talked about is if you have a low producing well, you might want to use a secondary tank, or you might want to oversize your pressure tank. So low producing well could go into a big storage tank like you see behind me. That's a 2,500-gallon tank. Or you could have some larger tanks. The nice thing there is that pump could pump really slowly for like an hour, 2 hours to recharge your tanks. And then based on the volume of water you have in your store in your tanks, if you have a 100-gallon tank, you could use 10 gallons a minute for 10 minutes while your well is only producing a gallon a minute. But you're just going to be limited to like that 10 or 20-minute range that you have. You could use 50 gallons a minute for 2 minutes if you just have short bursts of water, even though your well is only producing a gallon a minute. So it buffers the system. It allows for high usage for shorter amount of times if you have a low producing well. Great. So I think that kind of wraps it up for today. I really appreciate everybody joining us, learning about pressurized systems. If this happens really common to me, is right after this, a question pops in your head of like, oh, great, we have a question.
Question, we got a couple now.
Nice.
Question from Kevin. Can a pressure tank lose pressure over time? There's a small tire-like pressure fitting on the top so you can refill the pressure.
Yep, great question. So yes, even our bladder tanks can lose pressure over time, not as common as the non-bladder tanks, because the non-bladder, like I said, that air is absorbing into the water on a daily basis and pulling that air out. But since we have that bladder separation, doesn't happen as much, but it can leak. On the top here, like you said, there is a little valve stem. Looks just like the one you have on your car, your bicycle. So you take your tire pressure gauge, you check that with the gauge, and like I said, you want 2 psi lower than your low set pressure. So this pressure switch, that was a 30-50. We want to see 28 psi out of here. If you have a 40-60, you want to see 38 psi of pressure out of here. If you have too much pressure, you use the back of that gauge and you bleed off some of it. If you don't have enough pressure, you can get your bicycle pump out, or you can get your tire pump out and pump that up to get the right pressure. So good to check this every once in a while. Like you said, over the matter of a couple of years, you do start to lose pressure in here. So I like to do annually, go out, check it out, make sure you have the pre-charge still in your tank.
And one last question from Dan. Does the spin down filter go between the pump and tank? Will the filter still work if the ball valve is downstream of the tank?
Historic. So like I mentioned, the ones I've seen on a different property here, it came out of the well, went through the spin down, and then went into the pressure tanks. And that was to try to get all of the sand out before it went in there. And then when we had the ball valve, that was after. That was on the outlet of the pressure tank side. Because like I said, you never want a ball valve between your pressure switch and the pump. You always want your pressure switch to be directly connected to that pump. And so there's never an accident of somebody not remembering and going and shutting off the ball valve, and then you burn up your pump. It happens a lot. The burn up doesn't happen a lot, but there are a lot of setups where people do put the ball valve in there. You could write a note on it. You could like wire it open. So just people don't accidentally, your kids don't go out there and play and shut it off. Great. So like I said, really appreciate everybody joining us today to go over our pressure tank and pressure system series, whether you're using a solar pump, an AC pump, a lot of different options there to create a very reliable and flexible water system. Because as soon as you create this pressure system, then a lot of that like consideration for how to set up everything else goes away, because all of those are set up and designed for our standard like utility water system that have anywhere from 40 to 60 psi. So once you set this up, you can put multiple stock tanks there, fill up those stock tanks. You could also fill up stock tanks and run it into your house. You just have your own mini utility type pressure system that you can do whatever you want with. So a lot of flexibility there. I went over a lot of stuff today. I really appreciate everybody sticking with me. Like I mentioned, this is going to go on YouTube, so feel free, watch it again. Some of these parts just didn't make sense, or it's like, I don't know, I'm just not quite sure if I'm making the right decisions here. Feel free to give us a call at 888-637-4493. We have pump sizers here, and that's all they do every single day is walk you through your water needs, walk you through what system's going to work for you, and walk you through a lot of these considerations of whether you want to do gravity feed, direct discharge, a pressurized system. They're going to help walk it through and then piece an entire kit ready to go for you. You can get the whole kit from us. You can get various components. Whatever you need is going to make it easier for you to set up. As a special gift for everybody joining us today, we do want to offer you a discount code on a complete solar pump kit, and that's going to be Field Day 50, Field Day 50. Enter that in or tell it to your pump sizer. They're going to give you an additional $50 off your kit for joining us today. Really appreciate it, like I said. Next week, we're doing our same time on Wednesday. We're going to do our next virtual field day. That's number 3 for September. And that's going to be types of submersible pumps, whether that's a helical or centrifugal, and the pros and cons of each. That's going to be really focused on solar pumps, our AC, our normal series and our pro series. So join us then. The following week, I'm super excited about that. And kick off the end of the month in September, we're going to be doing the different types of pro series pumps. We're going to get our pro series controller out here, and we're going to show the large amount of pumps that can work with. So if you have larger watering needs, that's going to be a great one to join. Again, you'll get an email, but that's at the end of the month. So really appreciate you joining us today, and have a great rest of your day.